Right now, everyone is obsessed with bigger context windows. Million token contexts, entire codebases shoved into a prompt, infinite history. Silicon Valley is treating context windows like horsepower in the 1990s. But they're solving the wrong problem. The real problem isn't how much data your LLM can read. It's how much garbage you are paying it to read that it doesn't actually need. If your autonomous coding agent is chewing through raw server logs, massive nested JSON payloads, or sprawling RAG documents, you are burning cold, hard cash on every single API call. You are paying a premium for a top-tier model to process whitespace, redundant keys, and repetitive timestamps. Enter Headroom. It's an open-source context compression layer created by Netflix senior engineer Tejas Chopra. It sits directly between your autonomous agent and the LLM. Instead of forwarding tool outputs verbatim, it dynamically strips the noise before the model ever sees it. The internet is already screaming that this tool will slash your API bills by 90% with zero loss in quality. But as engineers, we don't believe marketing. We look at the architecture. Let's look at how it actually works, where it breaks, and the exact math behind the hype. Most context-cutting tools are incredibly lazy. They use naive truncation or a cheap LLM summarizer to condense text and just hope for the best. That forces you to make a brutal engineering trade-off. Lower costs versus system accuracy. Headroom takes a completely different architectural approach based on two core components. First, content-aware routing. A JSON response isn't a build log, and neither one reads like plain English. Headroom's content router automatically detects the incoming data type and shunts it to a specialized, deterministic compression engine. For JSON payloads, it strips redundant structural keys, minifies spacing, and extracts schemas. For system logs, it collapses repetitive error loops and strips duplicate timestamps. For source code, it utilizes AST-aware filters to guarantee code correctness, frequently leaving the logic completely untouched to avoid hallucinated syntax. Second, and more importantly, compression is completely reversible. Headroom implements a mechanism called cache compress retrieve, or the CCR loop. When your agent pulls a massive data payload, the raw, uncompressed file is cached locally on your machine or server. Headroom passes a highly compacted version to the LLM. But here is the clever part. If the LLM is executing a complex reasoning task and realizes it needs a specific nested key or an obscure line from that log, it doesn't fail. It uses a native tool call to fetch the uncompressed segment from the local cache on demand. You pay for the short version by default, and you only pay for the long version when the agent explicitly asks for it. Because this tool operates at the transport layer, integration doesn't require rewriting your agentic workflows. It runs locally and hooks into your pipeline in three main ways. 1. As a transparent local proxy. You spin it up via your terminal using a simple command like Headroom Proxy, port 8787. You then change your agent's base URL to point to localhost. It intercepts your API calls, compresses the payloads on the fly, and forwards them to OpenAI or Anthropic without altering your application code. 2. As an MCP server, it integrates natively with the Model Context Protocol. This exposes the compression and retrieval tools directly into the agent's native toolset. 3. As an agent wrapper. Out of the box, it provides wrappers for environments like Claude Code, Cursor, Aider, and LangChain frameworks. It takes less than 5 minutes to spin up. But before you go adding this to your production stack, we need to talk about the data the AI influencers are deliberately ignoring. The headlines say, slash your bills by 90% universally. That is mathematically false. If we look at the project's own hard benchmarks, the token savings scaled drastically based on the exact payload characteristics. Look at the data. If your autonomous agent is an SRE assistant analyzing verbose system logs or a data agent parsing massive JSON API responses, you will see an 83% to 94% drop in token consumption. The math checks out. If you are running persistent, long-lived multi-agent sessions where context accumulates over hours, you will see a highly respectable 40% to 80% savings. But look at the bottom of the table. If your workload consists of short, back-and-forth chat conversations, compression drops to a measly 4.8%. Why? Because there isn't enough structural redundancy to compress without losing semantic meaning. And if your agent is strictly editing source code, the compression ratio is 0%. Headroom intentionally passes raw source code through unchanged to protect syntax tree integrity. So if your day-to-day workflow is just using Cursor or Claude code to refactor Python functions, do not expect miracles. This tool is not built for simple text editing. What about accuracy? The project notes a 98.2% recall rate on HTML extraction and identical reasoning capabilities on dense JSON benchmarks. But remember, these are project-maintained benchmarks. We are still waiting on massive independent third-party evaluations. Early community feedback from production engineers is exactly what you'd expect: mixed. Developers running standard coding scripts see modest savings of 10% to 25%. However, teams building complex, multi-agent data pipelines are reporting massive, compounding drops in infrastructure costs. The trade-off to watch out for is latency. If your agent frequently triggers aggressive compression, it may force multiple local cache retrievals, adding round-trip delay to your execution loop. Here's the bottom line. Headroom isn't magic. It is infrastructure. As we transition away from simple chatbots and move into the era of persistent, autonomous digital operators, managing your context token budget is becoming just as critical as choosing your underlying model architecture. Headroom attacks a massive hidden operational tax in agentic AI. Will every developer save 90%? Absolutely not. Will enterprise production systems processing high-volume structured data save thousands of dollars? Yes. And that is the fundamental difference between AI marketing and AI engineering. Links to the open source repository are in the description below. If you want breakdowns of actual AI infrastructure without the hype, hit subscribe. See you on the next one.